Can someone tell me how to find the vertex if I get something in standard form of a quadratic? Oh, it is a whole bunch of it. It's negative b over 2a. So negative b over 2a is a formula that you kind of want to have memorized for the test because it helps you find the vertex of standard form. And any parabola is going to be maximized at its vertex. So whether it's about area, this one is a rectangular fence. Here's my fence. It's around a garden, so one side of the garden is bounded by a wall. Here's my wall. Determine the maximum area enclosed inside this if the total length of fencing is 80 meters. So you want to write two equations. Alex, do you have this? You have 10, right? Okay, so if it's 80 meters, can someone give me a perimeter equation for it? L plus 2W has to equal 80. That's set in stone. I have that much fencing. How can I write an area equation to represent inside the rectangle? Just, yeah, W or length times width, W times L. That's the area of the rectangle. I want to maximize this formula. I can't do that if I have two variables. I can only maximize it if I have a function with one variable. So I want to take my perimeter equation and I want to solve it for one of the two variables. Which one is easier to solve for? L. L has to equal what? You could put it in that order, sure. Negative 2W plus 80, or you could write it as 80 minus 2W. It doesn't matter the order. So that can be substituted into now your area equation for L. And then you'll have an equation that just has one variable that you could maximize. So my area equation is W times negative 2W plus 80. So I use the perimeter equation to be able to solve for one of my variables so that my area equation will just have one variable to solve for. So now I can make this into a quadratic. Negative 2W squared plus 80W is the quadratic equation for the area. So if I maximize the area, I'm looking at the vertex of this parabola. So you could look at maybe a table on your calculator. You could look at the physical graph. To me, the easiest way is to use negative b over 2a to find that x value of the vertex. So once you find the x value, that's the width of your rectangle. Then you could figure out the length, right, from your total perimeter, and you could figure out the area by multiplying length times width. So I'd like you to try to finish that problem. This is b, right? So you're going to do negative b divided by 2 times a and figure out the x value of your vertex and then the rest of the problem. So what's the maximum area and what are the dimensions? My video here. So I'm going to do negative 80 divided by 2 times negative 2. So this is negative 80 divided by negative 4 is 20. So 20 is the width that will maximize the area in my picture. So if this is 20, that makes this width 20. I had a total of 80, so I have 40 left as my length. And then length times width, right? So 2 times 4 is 8 with 2 zeros. So 8 with 2 zeros meters squared would be my maximum area. Question? You what? Oh, this sake. Okay, so now you are trying example 2 on your own. So the two equations you would need for number 2, for perimeter, you have that 4x, right? There's 4 x's and there's 1 y. What do you have? A total of, was it 200? So that's your perimeter equation. Your area is still a rectangle, right? Area is still x times y, even though there's a bunch of x's to divide the stalls, but the width is still x. So you're going to solve this top equation for y. Y equals what? And then whatever you get here, you're going to plug it in for y in your area equation and then maximize that equation. So see if you can walk through the next 2 steps. And then you still want to do negative b over 2a and then solve for x, y in the area. 2. So here was my final answer. Here's my area equation, negative 4x squared plus 200x. So I did negative b over 2a, which was 25. That is that width of the corral. So I have 4 of those 25s. So I have 100 left over that makes up that other side length of the barn. So length times width gives me 2,500 as my area. Pick, hey, what do I want to review today? What do I need help on? What could I do on my own at home? I would still say spend a half an hour, whether it's in Flex or at home, preparing for tomorrow, because it's a lot of content. So, go back and circle. I really want to do these questions to prepare. So this whole front page deals with one of the objectives from your polynomial quiz. Can you graph the parent functions, absolute values, square root, exponential, I'm not going to focus on. So this is a nice to know, but if you want to skip question 3, exponential is not going to be tested on graphing it. Cubic function. So this whole front page is some of those parent functions, how to write their equation, their domain and range with transformation rules. So that's kind of objective number 1. Objective number 2 is all things quadratic. So I'm giving you standard form, vertex form, and intercept form. Can you graph a quadratic without a calculator? So both of these would be like non-calculator questions. So you might need more practice on graphing quadratics. And then we've got some facts about polynomials. Is it a polynomial or not? And then writing it in standard form, stating the degree, leading coefficient, turning points, maximum zeros, end behavior. Does the right end go up or down? So I'm going to go back and just do 12 and 14 with you in a minute to just kind of review those ideas. And then factoring, I'm going to leave kind of the easier ones for you, but you've got difference of squares, greatest common factor, box method, trinomial. But I was thinking we might want to review those 3 strategies, quartic form, grouping, and cubic formulas. I would give you the cubic formula on the test. So you don't have to memorize those cubic formulas, just how to use them on 24. So from that page, maybe that's what we'll do together. Then this is a good kind of check for a little bit harder question. So can you find the end behavior and all the zeros? And you could look at a graphing calculator. So this would be a calculator page type question on your test. And then here is one of those, here's a maximizing or an open box volume formula from day 1. You did 001 in your notes. So if you have to look back at 001 and average rate of change. So I think you had to do problem 004, 007, and maybe we did 17 deer population. I can't remember. Maybe we haven't done 17 yet, but you should be able to find average and instantaneous rate of change. If you need some help reviewing that, I'm not going to do that with the class, but I will help you. So that's polynomials. And then rational functions, I was just going to pick the one that had a hole in it to do, and I'm not sure which one that is. I think this one might have a hole. Let me just check. 2 times x plus 1, and then this is going to be x plus 1 times x plus 2, right? So I'm going to do number 4, finding the hole with you in a minute on 25. So you've got the front page if you want to work through it. So I'm just going to try to skip to number 12. Can everyone go back to number, sorry I'm jumping around. There's just a lot to cover. I want to make sure I get to some of it and give you time. So number 12. Standard form, you look from highest to lowest. So I need to put this negative 2x to the 5th in front of this whole polynomial. Negative 2x to the 5th plus 5x cubed plus 2x squared plus x minus 3. Maybe if you don't remember the vocabulary, like this is a 5th degree polynomial, but could you name a cubic trinomial or quadratic binomial? You might want to look over the naming vocabulary for polynomials. I think polynomials we covered on like 015 set of notes if you wanted to look back at that. What is the degree? The degree is the highest exponent power. So the degree is 5. The leading coefficient is what comes in front of that term. So the leading coefficient is -2. Maximum number of turning points. We talked about this briefly, but if you have a quadratic x squared, how many turning points does it have? 1. If you have x cubed, here's an exaggerated x cubed. How many turning points do you have? 2. So the rule for maximum number of turning points, it's 1 less than the degree. So my max turning points for a 5th degree function is 4. There could be 4 turning points, but there might not be. Like a cubic function might not have any turning points at all. A maximum of 2, but it might have 0 turning points. So this might have 0 turning points. Maximum number of zeros. That is equal to the degree. So a quadratic, it might cross the x-axis twice. Degree of 2 could cross the x-axis twice. It might not cross the x-axis at all, though. Cubic functions, they could cross the x-axis 1, 2, 3 times, but they might only cross the x-axis once. So it's called maximum number of zeros. So my max zeros is 5. It doesn't mean there has to be 5 zeros. And then the end behavior rules, you look for standard form. So number 14, this is in standard form. So that's my leading term. -8x to the 4th is going to tell me all that I need to know. The right end is going to go down. -8. A negative coefficient tells me that the right end goes down. Just like if you had -2x squared, right? The right end is going down on the graph. If you had the linear function -1/2 x, right? The right end is going down on the graph. So this is going down. The left end depends on the degree. This is an even degree, x to the 4th. Even degrees go in the same direction. Odd degrees go opposite directions. So if we already went down on the right, we have to go down on the left because it's an even degree function. Odd, opposite, even goes the same way. One other thing that students sometimes have trouble with, if you had like x plus 1 squared times x minus 4 cubed, what would you call the degree of this function? No, because this is not standard form. If I multiplied all those x's out, this is an x squared quadratic, this is an x cubed cubic, x squared times x cubed. This actually has 5th degree if it was in standard form and you multiplied everything by everything. So when it's in factored form, you technically are adding the total powers together. If this had been, x to the 4th plus 3x squared plus x plus 8, 4 is the degree because this is in standard form. You don't add them together in standard form. And the other thing I didn't see reviewed on here is multiplicity. Oh, I think it might be talked about on the back page, but what is this x-intercept right here? X plus 1 gives me an x-intercept of -1, right? My x-intercept is at -1. What's its multiplicity? Its multiplicity is 2, which is even. Do you remember what happens at an even multiplicity 0? Multiplicity is 2, which is even. This one, what's it do, Krishna? Oh, you're thinking about end behavior. I'm thinking about the multiplicity of the zeros. If the multiplicity is 3, which is odd, it's going to cut through the x-axis or bounce off the x-axis. 1 second. Can I finish the thought on multiplicity real quick? This is parentheses x plus 1 squared. This is all on those notes on polynomials. X minus 4 to the 3rd. I just want to show you what the graph looks like. We said that there's an x-intercept at -1 and an x-intercept at 4. See how we're bouncing off the x-axis right there, and we're cutting through the x-axis right there? So knowing the multiplicity of the x-intercepts helps you graph it. So you want to review multiplicity and degree in factored and standard form. Question ohm. How do you find multiplicity? It's the power of that factor. So if I wanted to write this out in factored form, it would be x plus 1 times x plus 1, x minus 4, x minus 4, x minus 4, right? Because that's what x plus 1 squared means. X plus 1, x plus 1. That's what x minus 4 cubed means. How many times did this show up? It showed up twice. Oh my gosh, what are they doing? How many times did this show up? It showed up 3 times. The multiplicity refers to how many times does that factor show up if you multiply it out. So, last but not least, before we stretch, I wanted to review these 3 types of factoring. I think this is on 012 of your notes from virtual week. I didn't ask these, I don't think, on your polynomial quiz. I stuck to the other kind of basic factoring strategies, box, GCF, difference of squares. You know, there might be one out of these 3 strategies as one part of a factoring question. So if I had a factoring question, I had part A, part B, part C. Maybe for part C, I would draw out of one of these 3. You know, so you could still get a 3 or a 4 on that question and not know how to do these factoring strategies, but it'd be nice to know. Quartic form, when it goes x to the 4th, x squared, and a constant term, if you rewrite this as a quadratic, I know it seems weird to do that, but if you think of this as x squared plus x minus 20, this is easily factorable using the diamond method. You're looking for the factors of negative 20 that add up to 1. So what would that factor into? What are the factors of negative 20 that add up to 1? Yep, positive 5, negative 4. This is not x to the 4th in power. So what you do is you square each of your x's inside the parentheses. X squared plus 5, x squared minus 4. See how now x squared times x squared is x to the 4th. Outer plus inner is 1x squared, and you still get your negative 20. Can either of these go a step further? Hopefully your brain is like, ding. Which one can go a step further? This is difference of squares. This can't, but this can. So my final factored answer, x squared plus 5, x plus 2, x minus 2, will help me find all of these zeros. See how it says equal to 0? What are my 2 solutions to this problem for x? X is 2 or negative 2. And I'll just say, because we have so much on this test, that there'll be no imaginary numbers. You know, so you don't have to solve this because that produces what? Plus or minus the square root of 5i. It'd be nice to know, but I won't put complex numbers on your test. So one thing you can cross off your list, okay? Yeah. Because did you see how it was x plus 5, x minus 4, right? Because it's the factors of negative 20 that add up to 1. So I need to, instead of having it be a quadratic, I need it to be a quartic, x to the 4th. So x squared times x squared is x to the 4th. So it's a strategy. It's called quadratic form. You use quadratic form to get to here, and then you just square both of your x's, and it gives you that quartic formula. It's just one strategy that you probably hadn't seen before that one virtual day. Number 22, you can either use the box method and just put those into the box, or you could do the grouping method. So if you're going to do the box method, I'll set it up for you because most of you probably like the box method. So if you're going to do box method, it would be x cubed, 2x squared, 3x, and 6, and then you do the box method. If you wanted to do the grouping method, it's x cubed plus 2x squared in one parentheses and 3x plus 6 in the other parenthesis. So I'm going to give you a minute. Try the box method first, and then I can just show you how you get the same answer using grouping. But I think if you're good with the box method for this test, maybe you want to stick with that. So if I did the box, it would be x squared times x. This would need a 3, and this would need a 2, right? So x squared plus 3 times x plus 2 would be my factors. So my only x-intercept would be at -2, right? Grouping wise, you're basically doing the same thing. You're pulling out a greatest common factor. So if I pull out x squared, I have x plus 2 left. If I pull out a 3, I have x plus 2 left. If I pull out an x plus 2, see how I have x squared plus 3 left? It gets me to the same place as the box method. So if you like the box method, maybe that's your method for this test, not trying to figure out grouping. All right. And then the last one, I just wanted to remind you of the cubic formulas. I think those are on the 012 page. I would put them on the test for you. The formula for this one, a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. So that formula would be printed on the test. And then if you had to use it, you know, maybe it'll be a bonus question, but we're going to see factoring again just kind of throughout the year. I'm not going to give you a rational function with a cubic, you know, in it. But so if I took the cubed root, see how I go from a cubed down to a, I would just have 2x left. And I would just have the cube root of 27 is 3. So this cubic or sum of cubes factors into 2x plus 3 as my binomial. And then I'm doing all these things on my binomial. So a squared, 2x times 2x would be 4x squared. Then it says put a minus sign. Then I'm multiplying these two terms together, so I would get 6x. Then it says put a plus sign. And then 3 times 3 is 9. This is usually not factorable and not producing any solutions. So my only x-intercept would be at -3/2 if I solved for x. But like I said, you know, I might put one of these on as a bonus or a part C of a question. So I wouldn't let that, you know, spend your focus, but I think that was something to revisit. And the last one I wanted to do was just showing you how to find a hole on number, what did I say, 4 on the rational function review. I'm not going to go through graphing this whole question, but just how to find the hole. You always factor the numerator and denominator first. I kind of already factored it because I was making sure there was a hole on this question, but I did a greatest common factor. This is number 4 on page 25. Number 4 on page 25. Factored out a greatest common factor, and I figured out the diamond method, basically. What are the factors of 2 that add up to 3? So x plus 1 cancels. My new rational function is just this, 2 over x plus 2. Yeah, that's it, I think. Number 4. So you're going to go ahead and answer all these questions yourself. I would at least try to do a couple rational functions for review. Maybe find one with a slant asymptote for review. But if this is my new function, how do I find the hole? So the hole is at -1 because that's where this denominator was originally undefined. So I didn't write down, oh, here we go. A, find the coordinate of the rational function's hole. It's at -1, comma, I'm going to plug -1 into this function. Denominator would become +1, right? -1 plus 2. So 2. is my y value. 2 divided by 1 is 2. So I know there's a hole at -1, 2. So now I can proceed answering all these questions about this circled function. So maybe you want to start with number 4, and we're going to go for a walk, and then you can pick through the review sheet.